Here we're asked to solve this equation or find all of the zeros or roots or x-intercepts of this equation. So I'm really looking for what x values make the entire equation 0. To start us off here, I am going to look to find all possible rational roots. So when I use the rational root theorem here, all of the possible rational roots are all of the factors of my constant over all the factors of my coefficient, which in this case is just 1. So when I look at these here, my possible rational roots are positive or negative, 1, 2, 4, and 8. Now, there might be some non-irrational roots, and we'll find those as we go. So to start, I'm going to try plugging these in using synthetic substitution or synthetic division, since we're going to be pulling out and factoring this original. So I'm going to plop down all of the coefficients here and bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and since I get this remainder of 0, that is a good thing. That means that one of my roots is positive 1, which I'll come back to, and one of my factors is x minus 1. And then what's left here gives me the rest of my equation. So x cubed plus 2x squared plus 4x plus 8. And now I'm going to keep going. I'm going to keep trying these rational roots here to plug into now my smaller equation, because it'll make it a little bit easier. So I'll next move on to negative 1 here. Coefficients 1, 2, 4, and 8. Bring down the 1, multiply, add, multiply, add, multiply, and add. Okay, not a root because I don't get a remainder of 0. So I'll go ahead and try negative 2 next. I'm going to try a negative number because since all of the coefficients of this one here are positive, I know it has to be a negative number, because if I plug in a positive number, it's just going to keep multiplying and adding and never go down to 0. So I'm going to bring down, multiply, add, multiply, add, multiply, and there we go. I get my second remainder of 0. So that tells me two things: that negative 2 is a root or a solution, and that x plus 2 is part of my equation. So I have x minus 1 from the original one here, x plus 2 from what I just found here, and then what's left over, which is x squared plus 4. Now I could keep going and plugging them in, but I have this quadratic here that I know if I solve that, is going to give me an irrational answer. So what I mean by that is, if I were to set all of these equal to 0, I know that x equals 1, which makes sense. X plus 2 equals 0, x equals negative 2, which makes sense. And then x squared plus 4 equals 0, x squared equals negative 4, square root both sides. X is going to equal positive or negative the square root of negative 4. Square root of 4 is 2, and if it's negative, I know it's imaginary. So that is my third and fourth root or solution to this equation. So what I mean by that is, remember that our original equation had x to the power of 4, so I should get 4 solutions here. 1, negative 2, positive 2i, and negative 2i.